In this lecture, we are going to go over implementing in our iterator for our binary search tree. So, like in previous lectures, we need to start off with creating our binary search tree iterator. And this iterator obviously needs a lifetime and then our type, where T implements the OR trait. And then our field in here is going to be a stack for us to store our values. And so we're just going to simply use a vector, and then we will need our binary search tree of type T. And we want to get rid of that. Alright, so that looks good. So now we want to create an implementation block for our binary search tree iterator. And then do the same thing where T implements the OR trait. And now we are good to go. So we will say pub f and new so that we can create our new iterator. We will have a tree being passed in, which is going to be a reference to a binary search tree. And then what we're going to return is a binary search tree iterator of type T. So inside of our new method for our iterator, we will say let a mutable iter is a binary search tree iterator. And now we want to initialize our stack. So we'll use the vec macro and we will create it on the tree value that we pass in. So what I want to do is actually create a helper function called stack push left. So we'll do that next. And then from here we will return our iterator. So our stack push left is going to be a helper function, and it's going to contain a mutable reference to ourself. And what we're going to do is say while let sum child is equal to a reference to ourself stack dot last dot unwrap dot left. So we want to get the left value out of our child that is being passed in, and when we do, we want to stack dot push that child. So we're pushing that left value into our stack. So what this is doing is it's getting all of the left values out of our tree, and this is going to help us when we implement in our next method, which we can do right now, and I'll be able to explain it all once it is set up. That way it's just to make sure it's super clear on what we are doing. So we're going to have our binary search tree iterator here, where T implements ORed, and then inside of here we will have our type item, which is of reference to our lifetime of type T. And now we have our next method, which contains a mutable reference to ourself and returns an option So what we can do here is now say if self dot stack dot is empty, then we can return none. Otherwise, we have some values that we can work with. So we will say let node equals self dot stack dot pop dot unwrap, so get the values from inside of what we just popped, and then if node dot write dot is sum, meaning that there is a right value. Then we want to self.stack.push our node right as a reference, dot unwrap the value, and then dereference it. That way we have the actual value inside of it. And then we want to push it left. Self.stack push left. And now we want to return our node value as a ref. So what we're doing here is in push left, stack push left, we are getting all the left values and pushing them onto our stack here. When that left value is on the stack, we're using that inside of our next value, and we're checking to see if that left value, aka that node, has some value also to the right of it. So if that node has a right value, and if it is, then we're going to push that onto our stack. So what our iterator is doing is it's getting all the values from least to greatest in our iterator. So when we iterate through our tree, we're always going to get the least greatest value first, and then the very last value that we iterate through will be our greatest value. So our tree, when we iterate through it, will always be iterated from least to greatest. And we'll be able to see that this holds true when we do our iterator test. So the last thing that we need to do now is implement in our iterator method in our binary search tree implementation block. So this is going to return a new iterator which iterates over the tree in order from least to greatest. And so it's going to be pub fn iter and self, and it's going to return the iterator trait, so impl iter where item is equal to and reference to our t value, and then very simply in here we will say we want a new binary tree iterator on our self. So this is passing in our tree right here. Alright, so all of this looks really good. So let's implement in our test cases for our iterator to see how everything is looking. And I renamed our create function here to create tree just to have it make a little bit more sense. So we have our test case, and our test is going to be called test iterator. So we have our let tree equals create tree, and now that we have our tree, we can say let mutable iterator equals tree.iter. So now we are creating our iterator for our tree, and now we can start doing our assert equals. So remember, I said that we are going to have an iterator that goes from least to greatest in our tree at all time. So that would mean we'll go 0, 5, 7, 15, 27, 34, and 43. So that is what I'm expecting our iterator to do down here. So we'll go 0, 5, 7, 15, 27, 34, and 43. So let's put all those in. 0, 5, 7, 15, 27, 34, and 43. And then for our last one, so now that we know that our iterator is at the end, we will say our iter next, and we expect none to be returned. So everything, I believe, is good. So let's run our test and see what we have. We get an error saying no method named dref. So we need to import dref into our scope. That's a very easy fix. Thank you, compiler. So now if we run test again, we see that our test passes successfully. So what our iterator is doing, again, it is iterating the tree with values from least to greatest. So this would mean that our tree is going to be very easy to search for values for. And searching is the next implementation we will do, and we will begin working on that in the next lecture.